Hello, Assalamualaikum everyone. This is Zainab from DICE Analytics. I would like to welcome you all on behalf of DICE for the free demo class on DevOps. Today's webinar will be conducted by our lead trainer, Mr. Ali Kahoot. Mr. Ali is a software and DevOps engineer with extensive experience in software development and developing CI/CD workflows for complex applications consisting of different various microservices. He has been working on tools like Jenkins, Docker Container, Kubernetes, Helm for years. Currently, he is working as a senior DevOps engineer at Tarabut Gateway. In today's session, you will get to understand what is actually DevOps. You will get to know the process of continuous integration and continuous delivery, the essential technologies required to move to DevOps, its best practices. Mr. Ali will also be guiding you about why you should move to DevOps and why it is one of the highest paid jobs. So don't forget to note down your queries during the session and ask them with the lead trainer at the Q&A session at the end. Thank you so much. Over to Mr. Ali.
Thank you, Zainab. Thank you, Zainab, for the introduction. Hello, everyone. I hope all of you can hear me fine. Zainab, can you confirm that?
Yes, we can hear you and the screen is visible.
Okay, thank you. So yeah, hello again. Welcome to Intro to DevOps. So basically, in this session, we would be going through why basically you should move to DevOps and different trends and all. So before starting, let me introduce myself. My name is Muhammad Ali Kahoot. I am currently working as a senior SRE, site reliability engineer at PavaPay, which is a UK-based fintech company, which operates in Africa region and Europe region. I'm working fully remotely over here. I was previously the former senior DevOps engineer at Tarabut Gateway, which was a Middle East-based fintech company which operated in open banking. Again, it was a remote opportunity. I am also a part-time DevOps trainer at DICE Analytics. So we have different batches of DevOps courses from time to time, an 8 week course. I am also a DevOps consultant at multiple places. So where I give my consultancy services and freelance consultation to different customers. I was the previous team lead at Staycator Aurora Solutions, where I led the team for Staycator, basically for expanding the DevOps team and managing. Basically, we provided DevOps as a service solution to our customers. I was also ex-software engineer at Bentley Systems, and I am an avid open source contributor. So apart from that, I have done CKAD, the certified Kubernetes application developer. I am Oracle Cloud certified. I am Red Hat certified in OpenShift. I have a blog on Kubernetes with more than 150K views and 2.8K claps on Medium. So basically, it's one of the best blogs and one of the highest, first rated on Google. I have trained more than 400 resources on DevOps and Kubernetes. On Plural site, I am a certified expert in DevOps, Docker, Kubernetes. I have been public speaking at multiple events, DevOps Con, Singapore, Google DevFest, S&P DevOps Week, Data and Kubernetes, and have conducted more than 10 boot camps on Kubernetes for worldwide professionals. So that was a detailed introduction of mine. So just so you guys know that basically we at DICE, we always prefer to have experienced professionals as trainers. So I personally have a lot of experience in DevOps. I have trained people, I have led the teams, I have built the infrastructures from scratch. So I know all the different paths and all the different issues that one faces when moving towards a DevOps path or anything. So today's agenda again, what is DevOps, a little bit difference between Agile and DevOps, DevOps trends, what is CI/CD, what are the major tools required to move to DevOps, and those things. So again, yeah, what should I do when I need DevOps? So the basic question arises. So I will ask some of you, if you can guys can tell in chat or anything what you guys think, or if anyone of you wants to speak, he can chat and I will allow to talk to them. So if any of you can tell me what DevOps is according to you. I will just wait for 2 to 3 minutes. So if you guys can basically tell me what you guys think, what DevOps is before I jump into it. when you want to automate releases. Yeah, sort of one phase of DevOps is this. Okay, anyone else? Okay, I believe let's get start. Let's move. I believe I cannot see any other message on the chat. So yeah, let's move on. Okay, so there is something else relating to development and implementing, build up a comprehensive system. Yeah, sort of related to development and operations. So obviously, yes, DevOps is a mixture of development and operations. So this is a combination of both of those things. So you can guess that it has a bit of the operations side as well. You have to do the operations things and development as well. And continuous integration, yeah, build up a comprehensive system, integration of the package. Yeah, all of these are somewhat correct. So now coming back to why DevOps is boosting and why DevOps is booming nowadays, and what was the problem that DevOps solves. So everything, so basically in 2000, so early 2000, 2005, 6, 7, so every company needed a software. So each and every company, they were moving towards a digital work, and they wanted a software for their company, a mobile application, a website, or anything else. So whatever they want, they had need to have a software. So at that time, software developers were quite in demand. So even you guys, most of you would know that at that time, software engineers were quite in demand because companies were shifting towards a digital phase. They were shifting to have softwares. But now at this moment in 2020 and 2022, all the companies have software. Some companies are creating more softwares, but most of the companies, 80% companies already have a software. Now they want to manage it. Now they want to maintain it. Now they want to release new versions of their software. Now they want to release new features rather than creating a new software. They want to release new feature, and they want lesser and lesser downtime. So even to now, we faced a downtime from Zoom. So I don't know if you guys experienced it or not, but I experienced it when I was trying to sign in at 7:30. It was having an error at Zoom backend. So I could not sign in at that time, and I believe they fixed it somehow. But as you can see that if you are that much of a global company, you cannot basically experience downtime, and you cannot have downtimes, such frequent downtimes, because thousands and millions of people are waiting upon you. So if you have a downtime or anything, then that would bring a lot of bad name for you. And then there are a lot of competitors. So for example, if Zoom faces a lot of downtime frequently, most of the companies would move to any other software, for example, Google Meet or Google anything, or anything for that matter. So people would shift from Zoom to their competitor. So the problem is that you want frequently new features. Every company has software. Now you want to maintain it. You want to diagnose issues on the server. So what happened, why it happened, and now you want an incident report on it, that okay, how could we improve on it in the future? And then blames also start shifting. So the developers would be shifting on the ops guys. I'm telling, before DevOps, what happened was that the people started shifting blame towards each other. So some guys were blaming the ops guys were blaming the developers, and those sort of back and forth went on and on. What was the result of it? The result of it was that uh, what do you mean by downtime with respect to DevOps? Okay, so what I mean by downtime is that, for example, if any application goes down, so for example, I don't know if you guys know, remember it or not, Facebook went down a little time ago. I think so. It's 4 to 5 months ago, Facebook went down. So Facebook.com was not accessible at that moment. So every application that was using Facebook, that also got affected. So this is called downtime, that how much time Facebook.com remained down. So as a DevOps engineer, our purpose is to have 100% uptime, zero downtime and 100% uptime. That means that your application should be up all the time. So now coming back, the result was that there were delays when deploying to dev environment, waiting for confirmation, moving to QA environment, and then again manual confirmation, and then moving to production. So this took a lot of basically again back and forth blaming and back and forth requesting. So the developers were requesting the QA that, okay, please test this version of my software, and then it will go to the next environment, then it will go to prod, then you would be requesting operations. I myself have worked in such companies where you had to fill lengthy forms. So basically, if we wanted our software to go to production, our new version, our new release, so we had to fill a full form of it, that okay, we have done all the testing, we have done all the penetration testing, all the performance testing, each and everything, all the libraries are error proof, and all of those things. We had to fill a form of it, then give to the ops guys, then ops guys would pick it up, then they will deploy it to production. I myself have worked in such companies where it used to happen, and then they were trying to move towards a better approach. So the result was that it can take days to release a new version of a software. And what happens is that once you release the new version, you take feedback from the customer, and customer says that I do not want this. So again, there is a popular saying in the software industry that customer never knows what he wants. Customer never ever knows what he wants. He basically, theoretically, he will be telling you hundreds of things that might not even be possible. He would be saying you that change this button to the over here, and if I click this button, any magic should happen or anything. But that's not how it's possible. Being a developer, you know that this is not possible. So coming back, that customer doesn't know what he wants unless until you show him a demo, you show him a first iteration of your software, and then he tells you, okay, move this button from here to here, move this thing from here to here, change this feature from here to here. So that's how you get your feedback from the customer. But if this delay is already taking a month, so you developed a new feature and it took a month to basically release to prod, and then you took feedback from the customer, then customer asked for changes, and then you repeated this again. So you can again imagine yourself that one change is taking months to get deployed to production, and that's not what you want as a company. You don't want that thing to happen. So if you see in your daily life, so for example, the stories feature that Snapchat basically started the stories feature. WhatsApp copied it, Facebook copied it, Instagram copied it, all other major applications, social media sites, they all copied that basically feature, the stories feature. So if Snapchat had waited for it, or if they didn't improve on it, then they would have gotten out of business, because Facebook, WhatsApp, Instagram, all of these social media owned by Meta, basically, they would have gone far above them, because if Snapchat was slow in releasing new features. So that's now the race of 21st century, or now the race of the software industry, that you have to be on top. You cannot wait or have extra delays when deploying your software. Then one of the major issues that happened was that everything worked fine on the developer's laptop, but it never worked on the production machine. So I, as a developer, I have written a software, it works on my machine, but it doesn't work on the production server. Can any of you think that why it happens, or why basically such issue, and the same software, the same code is working on my machine, I am a developer, but does not work on the production environment, which is created by the ops team? So this is again a major issue. Can any of you think about it, that why this happens? If you can write it in the chat, I will come back to the chat, I will move on. But if you guys can think that why this happens, you can write in the chat. But again, the result was that the product delivery cycles continue to move slower and slower. Fewer and lesser ambitious projects are taken. Organization is no longer able to provide stable, reliable service to customers. So again, the customers would be moving towards any other company for that matter. Okay. So basically, because of difference of platform, we did not test the software like line, difference in versions of dependencies, missing dependencies on production, so the solutions were not scalable enough. Can be anything from OS dependent going on. Exactly. So all of these things can be the issues. So all of things that you have mentioned. So what happens is that I, as a developer, have Ubuntu on my machine, for example. I have Ubuntu installed. I am using Ubuntu for my local development and all. But when the code goes to production server, there obviously in production, Ubuntu is never used. Ubuntu is not that much of a reliable Linux flavor. There would be Red Hat Enterprise Linux, or any other Linux which is an enterprise grade Linux. So that would be used over there. Then again, the version differences. So I am using, for example, Java 8 on my local machine. I have installed Java 8, or Java 11, but on production server, Java 8 is installed. So I have written the code on Java 11. My machine is working fine. The code is working fine. But when it went to prod, there Java 8 is installed. So how can you run that application over there? Then, for example, I am developing only one application, but obviously in the production server, there would be multiple applications running. So I have MySQL, for example, 8.0, 8.0.28, for example, I have locally installed MySQL 8.0.28, but on production, they need 5.0 version of MySQL because another application needs 5.0. So all of these issues can occur, basically OS differences, version differences, port conflicts, software releases, basically different applications running on the same server. So locally, only my one application would be running, but on production, another team also has the same application or another application they are running on the same server. So a conflict can occur over there. So yeah, most of you have answered right. So now coming to the software delivery lifecycle, most of you, if you have a software background, you would have seen this picture quite often in your degree or in your, basically, whenever you read about it. So what happened was there was waterfall methodology where you discovered, basically gathered the requirements. You gathered all the requirements that what you want as a software, then you planned it, you created architecture diagrams, you created architecture for your software, you hired a software architect, you hired a cloud architect, and all of those things. Then you built it, then you reviewed it, and then you deployed it, basically. And then you asked feedback from the customer, and customer said, I do not want this. I want a lot of changes in this, for example. So then again, you would have to restart it. Then came Agile. Agile says to divide your basically a whole task into iterations, or whole application into different iterations. So you have 1 week iteration, 2 weeks iteration, or 4 weeks iteration, whatever your team decides upon. So you have different iterations, and then rather than building the complete application, you would be building some features of it. So for example, you guys agree that, okay, there are 10 features that need to be built. So we would be building 3 features in the first iteration, 3 features in the second iteration, and 4 features in the last iteration, for example. That's how you agreed upon. So now what benefit Agile gives you, that the 3 features that are built over here, you showed it to the customer after the iteration, you deployed it, you showed it to the customer gave feedback, you changed it in the next sprint or the third sprint, basically third iteration. And then those changes are reflected. So this was Agile. But what DevOps says is, Agile was also limited to the iteration. So you would be releasing the new feature at the end of the iteration. So if your iteration is 2 weeks and your feature is complete on the first day of first week, you will still be waiting for the iteration to end to deploy your feature. DevOps says, so over here you can see that design, code, test, code, test, code, test, and then deploy at the end of the iteration. DevOps says code, test, code is correct, you have tested it, you have confidence on your code, deploy it. If your feature is complete, irrespective your iteration ends or not ends or whatever happens, if the code is complete, the feature is complete according to you, deploy it to production server rather than waiting for anyone or anything to happen. So that's the basic difference between DevOps, or what DevOps preaches, that you code, test, and you deploy it as soon as it is ready. Agile also focused more on the customer and developer part. So for example, breaking the requirements into user stories, breaking the requirements into different cases, and then dividing them into iterations and all. So this thing, Agile covered that how the customer and developer would be working. So basically over here, you would have a product manager or a project manager that would be taking the requirements from the customer and basically creating the sprint plan for you, or basically the backlog for you. Whereas DevOps, it focuses more on how the developers and operations would work. It also focuses on customer, but customer would be, I would say, a small part of it. Majorly, it focuses on the developer and operations and the internal teams, basically. How your internal teams works together to basically achieve the same goal that your company wants, to release software. Rather than blaming each other, DevOps focuses on the uh, team matching of your whole organization or those things. So this is how things work in DevOps. So again, the major features of DevOps, or the major principles of DevOps, are continuous feedback and quick release or fail process. So for example, you gather feedback if the code is wrong, if the code is not correct. So basically there is an error in the code. You have such automation in place which will tell you that there is an error in the code, or there is a bug in the code or anything, and you will fail. You will basically quick release or fail. So if the code is correct, release it quickly. If the code is not correct, fail quickly and tell the developers. Again, I personally have worked in such companies where what happened was that there were nightly builds or there were weekly builds that ran. So after a week, you basically write a software, you build the software. After a week, pipeline runs, tests your code, and turns out that there are a lot of issues. Now developers would again go back and fix those issues. So wasting their time, basically. So DevOps says that if the code is correct, release it. If the code is not correct, if there is an error, fail fast and give feedback to the developer that why your code failed. So basically, having such automation that it will tell you that, okay, your code failed because of this, and the developer can work on it right away rather than waiting for the whole week to finish, then getting to know that, okay, my code was failing. So this, whenever you search for DevOps on Google or anywhere, so you would get some similar sort of a diagram over there. So again, you can see that this is a complete cycle. You plan, code, build, test, release, and deploy, operate, monitor. And then again, you plan for the next feature and then working on it. Then you release it as soon as it's completed. So these both parts, dev and ops, are part of the complete DevOps, I would say, life cycle. These are some official documentations. This is from Wikipedia. DevOps is a combination of software development and information technology operations. DevOps is a set of software development practices that aim to shorten the system's development life cycle. So yeah, this is again official definitions. You can read them yourself, get better understanding if you want. DevOps is a way to deliver software with shared pain and responsibility. DevOps ultimately means, yeah. So this is my definition that I basically, whenever someone asks me what is a DevOps, for me, for basically, DevOps means taking and maintaining correct code, error-free. So basically, when I say correct code, that means all the testing has been done on that code and all the tests have passed. No tests are failing, no automation is failing. So when I say correct code, that means that it includes all the testing, all the different parts of testing, different phases of testing, unit testing, integration testing, all of those have been done on that code. And from a developer's machine, so taking that code from a developer's machine to revenue generating prod awesomeness. So whenever I say prod, that means the production environment where your actual application is running. So Facebook.com is actually the production environment for Facebook. So this again, this is my definition for DevOps. And what a DevOps engineer does is, so this is the definition of DevOps, what the DevOps engineer does. So there is a lot of debate if DevOps is a philosophy or not. So what is the role of DevOps engineer in this whole process? It is to automate all the stuff in between. So from the developer's machine, that means his laptop. So basically having a version control system like Git. So having GitHub, Git, having a version control system over there and incorporating branch protection and such security rules on top of it. So that is your a DevOps engineer's responsibility to maintain that. Then coming to error-free code, so having pipelines built which will be testing your code, which will be running unit tests, which will be running integration tests, all of those tests on the code whenever a new feature comes in. That is also part of your job, writing pipelines. So Jenkins is a tool to write pipelines. Git is a tool to manage the version controls of your system, version control system of your software. And how to package your code, that is Docker. Docker containers are used to package your code and push them, or basically deploy them to production or any other environment. So all of this is your responsibility, and then managing that as well. Again, this is also another thing, maintaining. So if the production system or any system goes down, even if your staging system goes down, DevOps engineers would be the first one to be called upon and say that, okay, come on and look why this thing failed. So even if it's night, even if it's daytime, even if it's any time of the day, you would be called and you would be asked to look into why this failed. So this is some sort of the maintaining part is much difficult than creating part, because you have to maintain that uptime that we were talking previously. You have to maintain 100% uptime of your applications. Any difference in Docker versus Docker Desktop? So again, Docker Desktop is the way that runs Docker. So in Windows and in Mac, basically, I have also my Mac, so I would be installing Docker Desktop. So what Docker Desktop does is that it runs a Ubuntu, it runs a Linux VM, not Ubuntu, it runs a Linux VM at the back end, and the Docker would be running on that. So basically, it's a detailed topic, Docker, but main thing is the main concept is Docker, not Docker Desktop. Main thing is Docker. Docker Desktop is just a way, is just a package to run Docker on your Windows machine or Mac machine. But Docker is the main software that is responsible for packaging the applications or images. Docker is mini VM itself. Ideally, no. In Linux environments, no. Docker does not run as a VM. Rather, again, that's a complete different topic, that what's the difference between a Docker container and a VM. But in Windows machine or in a Mac machine, actually Docker Desktop, basically, it deploys a VM for you. It deploys a Linux VM for you behind the scenes. You don't know that. Behind the scenes, it's deploying a VM. So again, that's a detailed topic. If you come in the course, basically, we do touch this topic in detail. Unofficially, we can say, unofficially, we cannot say for Linux. We cannot say for Linux. Linux, for when you install Linux, or you have a Ubuntu environment, for example, then Docker does not install any VM. Then Docker is running on your host OS. So for Linux, you cannot say that, but for Windows and Mac, you can unofficially say that. Okay, now coming to why DevOps, why should you move to DevOps? Why are we even giving a course on DevOps, or why we want you to learn DevOps? So it's about the trends of DevOps, how DevOps is projecting in the future. Even now, as I already told you, that DevOps engineers or SRE engineers, site reliability engineers, they are quite in demand, because now companies want such people to manage their infrastructure so that there should be no downtime for their application. So this is some sort of a Google trend, that how it is gathering interest over time. Stack Overflow, I believe all of you would know about it. Stack Overflow is the one of the most used sites by software engineers. So this is a survey of 2018 by Stack Overflow regarding salary for different types of developers. So you can see DevOps specialist is at the top: Germany, India, United Kingdom, United States. I am pretty sure all of you would know what data science is, all of you would know what machine learning is, all of you would know what data engineer does. But DevOps, most people don't know. But as you can see over here, the DevOps is the highest paid job. This survey is done by Stack Overflow. This is for 2018. Then 2019, again, you can see DevOps is the highest paid job. This is Stack Overflow. Again, not my personal survey or anything, Stack Overflow, you all would know that it's the biggest website for software engineers. So DevOps is again the highest paid job. Data engineer, data scientist, front end, back end, full stack developers, all are in basically lower range. DevOps again, India, Germany, 2019. 2020, again, site reliability engineer. This is engineering manager. I am not sure if you guys can see it or not, but first one is engineering manager. Obviously, management positions have more salary, but DevOps site reliability engineer and DevOps specialist. So these two are the top salary ranges. Then comes data science, data engineering, and all of those things. So, but then again, in Pakistan, most people know what data science is, what data engineering is, what full stack development is, but no one knows what DevOps is actually and what potential it has if you move towards it. Again, engineering manager, senior executive, VP, and those things, then site reliability engineer, DevOps specialist. So this is for 2020. Again, DevOps is the highest paid job, and those from Glassdoor, an average salary is 115,000 for a DevOps engineer. This is from Pasha. Again, Pasha, you all know, Pakistan Software Housing Association, I believe. But Pasha is the official body for software houses in Pakistan. So over here, again, you can see game producer for the senior level professionals. Again, this is for senior level professionals. Game producer gets almost $412,000, and an average DevOps engineer salary is 258,000. Again, in Pakistan, even DevOps engineers, they are getting much salary than others. Why? Because there is quite a niche in DevOps. There is no competition as of now in DevOps field. So if you move towards it in right now, then there is a bright future ahead. At least from my perspective, I can say that. DevOps is the hardest job to fill. These are three different blogs from HR, basically different HR personalities, which they have said that DevOps vacancies will be the hardest to fill in 2021. DevOps positions to be the hardest to fill in 2021. And it is the #1 hardest job to fill for a recruiter. So basically, all of these are point of views or blogs from, if these are different references again. Different trends for DevOps. Microsoft acquired GitHub, IBM acquired Red Hat. So if you guys don't know, Red Hat is one of the biggest players in DevOps field. So IBM acquired it, Mirantis acquired Docker. These are some acquisitions that are happening in the field of DevOps. Now coming to how to become a DevOps hackerman or a DevOps engineer, and what tools and technologies you should be familiar with. So for a software, these three things basically are the artifacts of it. First of all, the infrastructure where your software will run. The infrastructure covers the storage, network, servers. If there is a container, then container engine, infrastructure automation, operating system. So this is the sort of the hardware or those things that you would need to take care of, infrastructure, which we say. Then comes the application, obviously, how your multiple applications would be communicating with each other, how they would be load balancing between them. If load occurs, how would you scale up them? How would you run them in Docker containers? How would you have pipelines? So all of this comes over in applications. And then comes operations, that now your application is deployed. Now you want to monitor it, that, okay, what metrics your application is giving, how much CPU is being used, how much memory is being used, and all. Your application is logging. So basically, whenever your application logs, you have to consolidate them at a central place. So this is logging, tracing, alerting. So if your server is using 80% of your memory, you generate an alert that, okay, this server is using 80% of the memory, an alert should be generated. So you go and upscale the server, or basically create a new replica of the server. So alerting is again one of the major things, because gathering metrics is easy, but you must have alerts on top of those metrics. So at night, even if something happens, you get an alert, okay, your memory is being used quite much, then you take action upon that alert then. So again, coming to how you can evolve these things using DevOps. So the first, there are different best practices for DevOps, infrastructure as code, and all of these. I would be covering basics of all of them now. So infrastructure as code. So we said that infrastructure is the main base of your complete software. So obviously you need infrastructure to run your applications on. So you need infrastructure as code. So all the infrastructure that you will create, that should be in the form of code. You need infrastructure to deploy applications, can be on-prem or on the cloud. You have to create hundreds of VMs or thousands of servers, storage or anything. It should be in the form of code rather than you going on the console and doing it manually. Infrastructure as code principle says that everything should be in the form of code so that it's auditable. It's basically you can revise that, okay, what changes were done and why, rather than I doing some changes manually and then I leaving the company. For example, I am hired in a company, I create infrastructure manually and then I leave the company. So now the new guy comes in, he would not know that why did I create this thing? Why did I create this server in this form, especially? So if it's in the form of code, he can also go and see that, okay, Ali Kahoot did this because of this reason. So there is a question, is there any specific language or framework for DevOps? No, there is no specific language, but there is a lot of sort of language. That's why, as I mentioned earlier, the DevOps is the highest paid job, and I would be coming to it, that why it is the highest paid job. One of the major reasons is that as DevOps engineer, you need to be familiar with a lot of tools. So even for infrastructure as code, now coming, just going forward. So you have 4 different major tools: Terraform, Ansible, Puppet, Chef, then GitOps. So these 4 to 5 technologies just for infrastructure as code. So you should be familiar with at least 2 to 3 of them. So this is just for infrastructure as code. Now would be going if in the next slides for the next topics as well, but you can only see that why DevOps engineer is the highest paid job, because you have to learn a lot of technologies. But yeah, one language can be YAML. Most of the things work in YAML language. So you should be familiar with YAML, how it works and what is the syntax and what is the indentation of it. Infrastructure and servers can quickly be created. Again, if it's in the form of code and I ask you to create hundreds of VMs, you can only change in the code, basically, that previously if you were creating one VM, now you just have to change the count to 100 and 100 VMs will be created. Rather than manually creating VMs, then you would have to go to the console and create each and every VM manually. Easier to govern changes in infrastructure resources. Again, the part that I mentioned, that if you want to see what change was done and why, you can easily look into it. So again, one part is that you have multiple machines and you want multiple software to be installed on it. So this server, you want Git installed. This server, you want Jenkins installed. This server, you want Tomcat installed on top of it. Over here, you want MySQL, for example. Over here, you want Nagios. So first step would be that you SSH into each of the VM. You install Git on this one, Jenkins on this one. You basically SSH into that VM and then install Git. This is the manual thing. But what if you have to do the same thing on hundreds of VMs? So you have 100 VM, you have to install Git on 100 VMs. How would you do that? Would you SSH into 100 VMs and install Git on each of that, then SSH into the other 100 VMs, install Jenkins on them? So that is not basically scalable. So your goal is, as a DevOps engineer, that my infrastructure should be scalable easily. How important is bash scripting in DevOps journey? So a question, it's very important. Bash scripting is quite important. So again, many people ask me this question, that is programming important in DevOps? Should I know programming? Should I know and my response always is that yes, you should know basics of programming at least. I myself am a computer scientist. I did my bachelor's in computer science from FAST and worked as a software engineer for 2 to 3 years and then moved towards DevOps. And I believe it really helped me because of that. So you should at least know the basics of programming, how code works, how code develops, and then obviously you would have to do bash scripting, as asked in the question. So you would have to do bash scripting as a DevOps engineer, because you have to automate stuff, and automation means scripting. So yeah, this was again that if you have to deploy one software on 100 VMs, how can you do that if you don't have infrastructure as code available? So recreation of environment becomes quite easy if you have in the form of code. You just have to run the script, you just have to run that command, and your whole infrastructure would be recreated. Deploy everything in an automated way. Main purpose is to have state and deployment manifest in any central place. Again, and because of auditability and those matters, all the code, that all the things, all the infrastructure should be in the form of code, because we can then revisit it, that why this happened and how. So there are different tools: Terraform, Ansible, Puppet, Chef, and it also leads to GitOps, which is the future of Kubernetes. Nowadays, every company is moving towards GitOps. So over here in our course, basically we covered a bit of Terraform, a bit of Ansible. We cover both of these in the, you can say, beginner to intermediate level. We cover both of these tools. So if you, because what happens is that some company would be using Terraform, some company would be using Ansible. So we cover both of it a little bit, so you guys can get familiar with both of them, and if needed, you can pave your way accordingly. Okay, thanks. Please brief intro of GitOps. Again, GitOps is a way of having all of your state, all of your infrastructure, all of your everything in the form of code in Git. So everything should be in Git rather than anywhere else. So everything should be in Git. A tool should be looking at that Git repo and syncing it with your cluster. So that's the basics of it. But for that, obviously, to understand this, you should know Kubernetes. Then you would know, understand GitOps in more detail. But the basic purpose or the basic principle of GitOps is that everything should be in Git. Every little thing should be in Git, and your Git should be the source of truth, or the GitHub repo or anything that should be the source of truth rather than any other place. Kubernetes is also container orchestration tool, so GitOps isn't popular, I think. What's your opinion? No. GitOps complements. GitOps is for Kubernetes majorly. GitOps is a container organization tool, so GitOps complements it quite well. As I mentioned, that most of the companies are moving towards GitOps. Even our company, we use GitOps. In my previous company, I implemented GitOps. So GitOps is the future for Kubernetes deployments. Cloud computing. So what is cloud computing? So basically, what cloud computing means is that you want to have some sort of any service you want. So for example, you want database, you want physical server, you want any other thing, anything basically the service related to software or infrastructure you want, you can buy that on the cloud. So for example, AWS, in AWS, you get to buy physical servers. You can buy a physical server of, for example, 8 GB RAM, 2 CPUs, 16 GB RAM, 2 CPUs, 16 GB RAM, 4 CPUs, or anything else. So rather than managing that server yourself, so previously what happened was that you had to buy a server yourself, you would have to manage it yourself. But cloud computing helps us in this form basically, that you can buy resources on the cloud, on AWS, on Microsoft Azure, on Google Cloud. You can buy resources over there, and you would be paying only for what you use. So for example, you don't have to buy resources permanently. You will only be paying for what you use. So if I am using 2 servers, I would be only paying for those 2 servers. So there is an hourly charges for that server, for that machine, for that VM that I would be paying for. So for example, I'm just giving an example. So it's 100 rupees per hour, for example, and I use that machine for 24 hours, then that becomes 2400 bill for me for that particular day. Then if I use it for a month, then I have to pay 74400, basically 7,44,000. for that month if it's a 100 rupee per month per hour charges. So that's how you, similarly, if you want a database, you can use cloud to provision that database. Pay for what your elastic resources. So again, if a load comes, if there is a lot of load on your server, you can buy another server. You can buy one more server at that time. And if the load basically goes down, then again you can delete that server. So now you again would be paying for only one server. Self-service, everything you need with the self-service access, you can go to the cloud console and create your resources accordingly. So these are different methods of clouds. So this is on-premise if you don't want to utilize cloud. So everything would be on-premise, and the blue things are you manage, and red things are that the cloud manages. For example, over here, you would be managing each and everything. You would be managing the physical server, the physical storage, the networking between those servers, the virtualization, the OS, the application, and each and everything. If you buy infrastructure as a service, so what you will get is you will get a server. The virtualization would be done, server, you would be getting storage would be automatically attached, networking would already be done, which the cloud will be managing for you. And you just install the OS, basically you tell it that what OS you want, it will provision that for you, and what middleware you want, you will install on top of it. So for example, I have a Java application, so I will ask for a Ubuntu, for example, OS, then install Java on top of it, and then install my application on top of it. If I am using a platform as a service, that means that I will be telling AWS, I will tell AWS that, okay, I need a Java machine. It will automatically provision for me a Java machine where the OS would be installed, Java would already be installed, only I have to copy my application on it, and then my application would start running. So this is a platform as a service. Then comes software as a service. So software as a service, basically example is Facebook. Facebook is a software as a service that they are giving us. They would not change anything for us. Everything they are managing. The Facebook UI, the Facebook messaging button, anything for that matter, you don't have any control over it. Facebook would be managing each and everything. So for example, if I don't like the Facebook UI, I cannot do anything about it, because that's how they are giving me that software as a service. So again, examples come, we read about infrastructure as code examples. Now coming to cloud examples. So there are Google Cloud, Amazon EC2 instances, platform as a service, Google App Engine, and these are different basically platform as a service examples. And then comes function as a service as well. So this is a new model or serverless model, basically, that where you tell your code, basically you host your code on the cloud, and the cloud will run it accordingly. So you don't have to create anything. You just have to create the code. You give that code to the cloud, basically you upload your code on the cloud, and now whenever you will call that code, AWS will automatically run that piece of code automatically. So that's serverless. So in actual, it is running on a server, but you are not managing it. Everything is being managed by cloud. You just write the code and upload that to the cloud. Now cloud will automatically run it. Whenever there is load, it will automatically scale it up. Whenever there is less load, it will scale it down. So this is a serverless sort of an example. Now coming to different clouds, again, as I mentioned, that there are a lot of tools a DevOps engineer should be familiar with. So AWS, Azure, Google Cloud, IBM Cloud, DigitalOcean, OpenStack, Oracle, DigitalOcean, and a lot of other tools, basically, other clouds are popular, which a DevOps engineer should be familiar with. So because one company would be working in AWS, other would be using Azure, or one of your clients would be using AWS, other would be using Google Cloud. So you should know the basics of cloud computing to understand that cloud. Sorry, the question is due to any possibility of recording. Yeah, I believe this is being broadcasted right now, so it would be available on YouTube or Facebook or Dice Analytics page, so you can refer to that as well. So these are different clouds that a DevOps engineer must be familiar with, or at least know one of them. Next is microservices. Now your physical infrastructure. So slide 2. Yeah, you can get that from DICE as well. So basically, infrastructure is provisioned, the servers are provisioned. Now you want to design your applications or you want to deploy your application. So microservices is a concept where you build a single application. So for example, you have one e-commerce application. You divide that into smaller applications or smaller microservices. Rather than having one big service, you divide them into smaller independent services. Each service runs its own process and communicates with other services through a well-defined interface. So for example, this is your e-commerce website. So for example, you work in Daraz and you have this one. Daraz, for example, is a monolithic service. So one is microservice, the opposite of it is monolithic service. There is one service only. And for example, Daraz launches a basically the Black Friday sale or whatever sale the Yara Yara sale, the 11th November sale, basically what they launch is, or a Black Friday sale, whatsoever, they launch a sale. So now what will happen is on that sale day, the major load would be on the products code, basically, because everyone that would be coming to Daraz website would be seeing the products. A few of them would log in, a few of them would be ordering something and getting some promotion or anything. But for example, there are 1000 people. So 1000 people would be coming just to see products. I'm giving just an example. In actual, obviously, it's relative to 1 million or anything. But for example, 1 million customers come, they would be seeing the products. Out of that 1 million, 10,000 would be logging in and basically ordering any product. So if it's a monolithic and you have load on your application, you have one database, so your application can choke. Basically, it will have a lot of load on it. So what microservices says is that you can divide this one monolithic into smaller services. So over here, you can see that each of the business unit is now divided into smaller microservices, each having its own database. So now even the database is divided. So microservices architecture, what it says is that you divide your big services into smaller microservices and divide the database as well. So now if again Daraz hosts a sale, now the load will only come on this service and you can easily scale it up. You can have another replica of it. Rather than creating replicas of each and every service, because the load is only on product service. So you can only create a replica of the product service rather than for the complete application. Yeah, so there are questions. How should we learn a cloud platform before starting DevOps? You see, DevOps is the, I would say, parent field. DevOps is the major field, then cloud is a smaller field or is a child field inside DevOps. So DevOps is the parent field. It covers each and every aspect of your application. The software delivery lifecycle, it covers the infrastructure. It covers, as I showed over here, just going back. So basically, DevOps covers the infrastructure, applications, operations. For cloud, but the cloud majorly covers the infrastructure part. It does not cover, if you are going towards a cloud specialized thing, then obviously you would be just be covering majorly this. You would not be covering the CI/CD, those things for the applications. So there are other questions as well. Is mean in microservices our data is distributed? Yes. In microservices, your database and your data should be distributed among different databases. Why? Because over here, so for example, in this diagram, let's assume there is one database only, all the microservices, and there is one database only. Then again, the issue that I said earlier, if all of the microservices are accessing one database, And if there is a load, if there is a sale, again product service is being used, product services is getting all the data from the database, then again your database would be your single point of failure. Try to understand this, that if you keep one database and your database goes down, then what's the purpose of dividing this into microservices? If the database goes down, each and every microservice goes down. We divided it into microservices to have independence of the services. So if products goes down, or for example, if promotions goes down, these four will not have any effect in a microservices based architecture. If promotion service goes down, these three will still be running. So if the promotions goes down, these four will still be running. So, and most of your customers, so for example, 80% of your customers will still not know, because they would not be using any promotion or anything. They would just be searching the products, they would just be logging in, they would be ordering. They might not use the promotion service. So if in a microservice based architecture, we always try to divide the architecture in a way that they are independent of each other. So there is a question, should we learn the cloud platform? Yeah, so this is already answered. It means these DB would be no SQL. No. Again, this also depends on your application. So this microservice, for example, has a relational database. This microservice has a no SQL, as a MongoDB or anything. This microservice again has a relational database. So this can be a combination of each and different databases. Again, the principle of microservice, that they are independent. So if they are independent, it does not matter what other microservice database is being used. If this is RDS, then this can be MySQL, this can be MySQL, this can be PostgreSQL, this can be MongoDB, whatever suits your microservice code. Does each microservices have their own underlying resources like storage, RAM, OS? That depends on how you deploy it. Basically, that is not stated in microservice. Microservice is just a code, the code division. How you deploy it, that depends on you, whether you deploy it in a physical server, basically deploy each microservice in separate servers, or you deploy them in containers. So then they will not be using separate resources. Yeah, Docker is used. Docker is the preferred use, or Kubernetes is the preferred way to use. But some companies even have microservices divided on different servers as well. That can also be done. That again depends on your architecture of your application. Then syncing of multiple databases not affects the efficiency and integration of database. Yeah, again, this is a very valid question, that how the syncing will be happening between the databases. So that again happens that in the accounts database, only accounts information would be there. So when you would be ordering something, you would be calling the account service and getting that data. Similarly, for example, if there is a product service which contains the information of the product, so in order service, you need the data of the product. Obviously, when you are creating an order, that order would be using the product's information. So then it will be calling this over a network call, over a basically distributed call, and getting that data. That database will not be shared or synced, but they, yeah, API calls. Exactly, Ali Razak. So there would be API calls between them. Order service. So over here, as when I said, I'm not going into much detail because most of you might not know what API calls is and those things. So when we said over here that each service runs in its own process and communicates with other services through a well-defined interface. So this well-defined interface is actually the API calls that they make to each other. Yeah, getting good response from the students. That means that you guys are understanding something. So yeah, how much networking is required for DevOps? I would say a little bit. Yeah, a little bit information about networking is required, but not that much. You can learn that on the go. It does not mean that you have to do a complete networking course and then go towards DevOps or anything. But because it's a very low information about networking, then you can gather on the way. Yes, exactly. Ali Razak has given the information about APIs. We can say that APIs can be used to get data from different DBs. Exactly. Not from different DBs, from different microservices. Then that microservice is responsible for having its own database and those things. And these are different examples of different big corporates. For example, Netflix, it has 500 plus microservices. So each of them is calling each other through an API and getting the response and showing that. Similarly, Twitter has 500 plus microservices. Amazon, you can see this diagram that how many microservices they have and how they have the API calls with each other. Similarly, Netflix and this. And then when you move towards microservices, as some of you questioned that how do we deploy it, and one of you answered that it's Docker. So yeah, whenever you are moving towards microservices based architecture, Docker containers, not even Docker containers, containers basically. Docker is just a runtime. There are other runtimes as well to use containers. So you use containers for it whenever you move to microservices based architecture. So containers are the most preferred way to deploy them. So as whenever your boss tells you we are converting to microservices, then you need containers for them. And this is a basically life cycle of a company, Bytemark, that how they moved towards a cloud native approach. So they had a monolithic application, they transited to microservices based architecture. So job applicants got another microservices, recruiters had a separate microservices, and job vacancies had a separate microservice. They created containers for their application, and then they launched those containers in Kubernetes. So this is how the complete architecture goes. First, you learn the basics of microservices, you create containers for them, you deploy those containers in Kubernetes. So any good company, or any, basically I would say a company with a good quality of code and good quality of architecture, it would be going through this same path. I myself have worked on this, that and how my interest basically started in DevOps was this, that I had a project where we had to convert a monolithic service to a microservice based architecture and host it in the cloud. And we did the same thing. We converted the monolithic to microservice, we hosted it on containers, we launched those containers on Kubernetes. So this is how I started learning DevOps. Now coming to the adoption, that why Kubernetes and why containers and these things. So this is some sort of a blog where 92% organizations were using containers in production, and 83 out of this 92 were using Kubernetes for containers orchestration. So these are quite big number. So if you, as I mentioned, that why DevOps engineer is in demand, if you know Kubernetes, so as you can see that companies are moving towards Kubernetes and containers. So this is the time to start learning such tools. This is the Red Hat basically survey, where 88% of the companies were using Kubernetes for container orchestration, and 74% of this were using it in production. So their production workloads are running on Kubernetes. Even for me, for the past, I would say my 3 companies, or for the past 5 to 6 years or 4 to 5 years, I have been working on Kubernetes majorly, and the companies and I have been basically preaching them to use Kubernetes, and they have had quite significant results in it. Basically, no downtime, no thing, because Kubernetes handles a lot of things. Uh, Kubernetes in itself is a quite a useful tool. But now coming to when you use microservices, and which most of the companies are now using, which most of the companies are now shifted towards microservice based architecture, you would be having an understanding of API gateways. So what an API gateway is, that it will be forwarding the request to the respective microservice. So you should be knowing about this. You should be knowing about messaging queues. So Kafka, RabbitMQ, Amazon Simple Queue Service. You should understand Kubernetes. And then there are even multiple ways of deploying to Kubernetes, EKS, different clouds basically. Similarly, Docker containers, there are different way to run containers. Then service mesh, this is again a a very new technology, or not a new, it has been there for 2 to 3 years now, but relatively it's still new. Service mesh, which is the future of Kubernetes microservices. Then serverless, as I mentioned already, that if you have a microservice, so for example over here, rather than hosting this yourself, you can just write a code and host it on this basically cloud in a serverless model. So then you would not be even using Kubernetes or anything. Then you would just be hosting this on a serverless model on AWS or any cloud. What is Docker Swarm? Docker Swarm is a competitor of Kubernetes. So basically, it is also a Docker container orchestration tool. It is a competitor of Kubernetes, but we have removed Docker Swarm from the course because Docker Swarm is not used in the industry anymore. If you see the comparisons between Docker Swarm and Kubernetes, Kubernetes is the much more preferred way. Even over here, as I showed, that this is the Red Hat basically trend, that 74% are using Kubernetes and those things. So Docker Swarm is a competitor of Kubernetes, but Docker Swarm did not do well in the longer term. I would say Kubernetes is the much more preferred way to deploy applications. So there was another thing, but we should first convince companies to use serverless format. Yeah, obviously, if you are the DevOps engineer in the company, this is your responsibility to guide them towards the better approaches and those things. But for that, first you should understand serverless yourself first. Then obviously you can advise on disadvantages of Swarm. You cannot say disadvantages of Swarm anything, but in comparison to Kubernetes, it's not that much used, or it does not have that much features. Kubernetes was open source. Kubernetes is open source basically, so it got a lot of benefit due to that. So many people contributed back to the community, and they added some features which were quite useful in the longer term. So you cannot say disadvantages, but again, if you see any survey or any comparison between them, so 90% of the companies would be using Kubernetes, 5% would be using Docker Swarm, and others would be using AWS, ECS, and those things. And these are different basically trends that I have seen myself. And that's why we discontinued Docker Swarm in the course. Now we focus more on Kubernetes stuff rather than Docker Swarm. So now again, this is the architecture of your applications. Now coming how to do the basically pipeline and how to deploy them on your infrastructure. Now infrastructure is complete. Architecture of your applications is complete. Now coming to how to deploy those applications to that infrastructure. So continuous integration is again a quite popular tool in Kubernetes, in DevOps. So basically what it means is that you merge the code changes from different developers into a central repository. So when you are working in a team, obviously there are multiple developers working on the same code. You have, for example, 5 members in your team. So all of them would be working on the same code base. So you just want, basically you want the code changes to be merged as soon as possible using CI techniques. Then automated builds and tests are run. So the point where I mentioned that the code should be correct. So how you can check whether your code is correct or not, there should be automated builds and automated tests that run whenever you push a new change to the code. Key goals are to fail fast and find and address bugs, as I mentioned earlier. So if there is any error, so I, for example, implemented a new feature. I have written a code for it. I pushed my code to the version control system. Now the pipeline runs and it fails. So obviously that means there was some issue in my code. The tests, they failed. Now I know that there is some issue in the code which I need to fix so that the pipelines should pass. So that's why the key goals is to fail fast. Benefit developers most, less merge conflicts. So basically, there are multiple developers working on the same code again. So as soon as they are merged, it will help them more. There would be lesser merge conflicts. So this is a company, how continuous integration is done in their company. They have showed a diagram. So basically, developers use Git, they push their code to GitHub, unit tests are run, code analysis is done, test coverage is done. And then obviously they release it when all of these things pass. The unit test pass, the code analysis pass, test coverage, they have a significant number, and then they release it. Then coming to continuous delivery, there is a question: in Kubernetes, Minikube installation is enough or with kubeadm? No, Minikube is just basically a local Kubernetes cluster. It's not a production grade system. So you can do some local testing with it, local basically know how to get to understand Kubernetes. You can use Minikube, but in actual you would be basically provisioning clusters on the cloud, whichever cloud you are using. So you would be provisioning Kubernetes clusters on that cloud, either in a managed form or in a, or you would be managing that yourself. But Minikube is just a basically test cluster that you can install locally to do some local testing and local knowledge gathering or anything. So basically, if you want a local Kubernetes cluster, you can install Minikube locally and try to run some things and understand Kubernetes. But and even in our stores, we use Minikube. But for actual understanding, we also deploy an actual cluster on the cloud. Basically, I deploy the cluster and I give access to all the students. They can run anything, or they can basically see how an actual cluster looks like. So continuous delivery will come after continuous integration. So once integration is passed, the unit tests are passed, and those things are passed, then what will happen is basically you will deploy your code on a test environment. So what is delivery? Integration is done. You have tested it. Now you deploy it on a test environment, basically a staging environment, a sandbox environment, a dev environment, any environment that is not production. So if any of you don't know, so what happens is in software, so for example, Facebook.com is actually the production server. But obviously, the code changes would not be going to production as soon as they are done. There would be some testing done on it. There would be done some testing. So what they do is they create a replica of the production environment, for example, named as dev.facebook.com. So us as users, we would not be able to access that, but their internal team, Facebook's internal team, they would be able to access that, and that would be named as their staging environment or dev environment or any other environment for that matter, whatever you name it. So what happens is that you have a staging environment or any other environment which is similar to production, and you deploy your application onto that environment. So this is continuous delivery, that you delivered the code up till a point which is similar to production. And the other terminology, when we say CI/CD, so there are two terminologies: CI for continuous integration, CD for continuous delivery, and continuous deployment. It can mean both ways. So continuous deployment, the difference between both of them is that in continuous deployment, after deployment to staging, you deploy to production as well in an automated way. But in continuous delivery, this thing is manual. So this is the major difference between delivery and deployment. So over here, basically you deploy to staging, you ran integration tests, you are now so much confident of your application, of your code, that you deployed it to production as well. So this is in an automated way, all done through pipeline, nothing manual. So this is continuous. The goal of a company should be to move towards continuous deployment. Everything should be manual, but obviously every company does not has that much better integration tests or that much automation, so they stick for continuous delivery. But as I mentioned, the goal is to move towards continuous deployment. How can a person with little background of hacking or bug hunting or cyber can make it to DevOps after taking your course of 8 weeks? I would say cybersecurity in itself is a complete field, and DevOps is a complete field. But if you are a person who has a knowledge of both, and you basically gather the expertise of DevOps and cybersecurity, you would be quite popular, or basically you would be quite, it would be quite easy for you to secure jobs, because both of these fields are niches. And if you are expert in both of them or have knowledge of both of them, then obviously you can easily gather jobs. Cybersecurity, as I mentioned, in itself is quite a niche field and quite a good field. And DevOps is again a quite DevSecOps. Yeah, that is what I was going to say, that you can go into DevSecOps roles. Personally, I don't consider DevSecOps a thing. Because security is part of DevOps. If you are saying DevOps, and when I mentioned the correct code, the correct infrastructure, then security is part of it. But this is my personal opinion. Companies are moving to hire a DevSecOps engineers. Companies are hiring for DevSecOps as well, where DevOps and security as well. But again, as a DevOps engineer, you should know basic security and basic things about security. It is part of your job, because if you are creating an infrastructure, so as I showed earlier, if you are creating an infrastructure that is not secure, then what's the purpose of automation? Basically, you are creating automation, but there is no security in your infrastructure, then what's the purpose of that automation or anything? Without programming, we can jump into DevOps. No, you should understand basic programming. Again, I would say that basic programming is necessary. I have seen many people who try this, but at the end of the day, you should at least be able to understand code. That okay, if I present a code in front of you, you should be able to understand that what's happening, rather than I would not say that you should be expert in programming, but at least of this level, that you should understand code, that okay, this is a loop, this is a if else situation, this is a for loop or anything. Please brief us for basic. So basic programming, as I mentioned, that basic shell scripting, for loops, if else, variables, and such sort of things. So basically, you should know this and try to write some bash scripting. Try to practice bash scripting, because that is what's used in DevOps the most. So yeah, this is again difference between delivery and deployment. So again, for monolithic and microservices, now what happens is that previously for a monolithic, if one team, their code doesn't work or their code has an issue, the whole release will be stopped. The whole release will be failed, and you would have to do release on any other day. But with microservices, you can see that if team B failed, only their change will not be pushed to production, but all the other 3 changes would be pushed to production. So this is the benefit of microservices and how it fits with the DevOps principles that I stated earlier, that you should release your software as soon as it is ready. Now coming to CI/CD tools, again, there are a lot of tools for it. And this is not what I am exaggerating. You go and see any JD of a DevOps engineer role, job description of a DevOps engineer, you will see most of these tools over there. The infrastructure as code tools, the cloud tools, the CI/CD tools, microservices tools, whatever written in these slides, you would see most of these tools over there. GitHub, GitLab, Bitbucket, all of them have their own pipelines. Jenkins, GitHub Actions, these are all their pipelines. Google Cloud has its own pipeline. Azure has its own pipeline. AWS has its own code pipeline. Flux, Argo CD. These two are the tools for GitOps that I mentioned earlier. So these are all different CI/CD tools. Okay, so there are some questions. Thank you. Sir, I have 8 to 9 months of experience and I'm now in 4th semester in BScs. How can I get internship in software company? So where you have experience without joining, so sorry, learning. Okay. So basically the question is that how can I get into DevOps? Okay, so one thing again being is that entry in DevOps is a bit difficult, because as you can see or basically understand from this, even all of this, that you would be the one person who would be managing the production servers of the company or production environments or other environments of a company. So most companies would be going towards hiring an experienced person, hiring a person who has enough knowledge base in it, who has enough experience in it, who knows what he is doing. Because in production environment, if you are testing or if you are basically learning as you go, then obviously you can have some pretty serious consequences on the company. You can fail their production servers or anything. So that's why if you have enough knowledge, if you have enough experience in that field, only then entry into DevOps is a bit difficult, as I mentioned. So for that, obviously, this course, many of my students have gotten quite good jobs after this course. The alumni of this course, uh, they have secured some jobs, but again, not. I would again say that the entry into DevOps field is a bit difficult because, as I mentioned, you would be managing the production environment for those companies. So that's why you are so valuable to that company. So when I say that the DevOps engineer is the highest paid job, so that's the one of the reasons that you are managing their production servers. If something goes down at any time of the day, you would be called, you would be responsible for it. So they would be willing to pay even a higher amount to you if you have some experience rather than saving some money over there and hiring an inexperienced guy. So DevOps is the main core behind handling the basically actual application. So that's why entry is a bit difficult, but the salaries are also quite good. So if you get enough knowledge and get into an entry level experience, entry level company or entry level basically a job, then you can easily secure a good job in 3 to 4 years. After 3 to 4 years, after gaining 3 to 4 years of experience in DevOps, you would be able to get. Also, there are in our course we provide hands-on basically practices and hands-on tasks that you do yourself and gain a bit of an experience to an actual environment. So yeah, now coming to monitoring, logging, and tracing. So as I mentioned, that once your applications are deployed, now you have to monitor them. You have to check whether their application is using more memory, less memory, more CPU, or whatsoever. Then consolidating all the logs onto one place, then checking the tracing, and then obviously if there is an error or there is an memory usage is getting high, then generating an alert for it. So for example, you would not be seeing the graphs 24/7. You would not be sitting in front of the graphs and seeing, okay, what memory is being used now or would that. Obviously, that's not the possible way. Rather, you would have alerting. So when a server's memory is being used 80%, an alert will be generated, an email will be sent, or for example, Slack message would be sent, and you can then react accordingly. So this is all the microservices. This is a central monitoring tool, which will be monitoring all the microservices, the central logging tool, which will be gathering all the logs from those. And obviously, this is again one of the most used thing if you have proper logging and proper monitoring, because for example, at night, 3 p.m., 3 a.m. At night, you had an outage, you had some downtime in your application. So now you will be asked to verify that, okay, why this happened, why this downtime occurred. So if there are no logging, are no logs, you cannot tell that why this happened. But if you have proper logging in place, you can go and see that, okay, at this time, this application gave this log, this server was having this much memory usage and CPU usage, and according to that, you can basically tell the management that, okay, this happened, that's why the application went down. Then again, coming to different tools for it, the managed cloud monitoring solutions, Prometheus, Grafana, these two are the most used tools for monitoring Kubernetes clusters. This is for logging, alert manager. These are all different tools for monitoring, logging. And then the last part, the last principle of DevOps would be the communication and feedback. So DevOps was introduced due to conflicts, as I mentioned earlier. So now you as a DevOps engineer want to have open communication and open feedback for everyone. So even if there is if the feature is correct and deployed, take feedback from the consumer. If issue is in the code, give feedback to developer again through CI/CD. And if there is an issue in infrastructure, so the DevOps engineers, they basically handle these three things, but they don't sort of follow this. So if there is an issue in the infrastructure, communicate to teams as soon as possible as well. So this should be this much transparent, that if there is an issue in infrastructure, everyone should know, rather than you hiding that because of that. But there should be such automation in that. So again, tools for it are Slack, Teams, Jira, and Alert Manager. So let me go to the questions. Thank you. Okay. How can we get experience when there is a requirement of 1+ year experience required for junior development? Yeah, again, as I mentioned, that this is the case, but if you have enough knowledge, you know what you are doing. And interviews, even in DevOps interviews, mostly what happens is, even in my experience, when I hire people, first there is the theoretical round where you obviously check the theoretical knowledge of the other person, and then there is a hands-on round that you give a hands-on task to the candidate and see whether he is able to complete that or not. What is average salaries in DevOps after 4 years of experience? So they are quite good, I would say. uh, you can go and see different salary brackets for average salaries, but I would say that they are quite, if you have 4 years of experience in DevOps, there would be quite demand of you in the market. Can you share recording? So recording would be there, simply the nice one and got better understanding. Thank you. Recording will be available for this. Yeah, so recording you can basically email Dice over there. Coming back to this, so the just finishing off, so DevOps requirements. Again, DevOps is not just about different things that we mentioned, or just about having a DevOps engineer position in your company. You should be agile first. So for example, when we mentioned earlier that it was a waterfall method, then came agile. So if you are not even agile, how can you follow DevOps? You should have stand-ups, you should have CI, CD in place, you have code testing or anything in that way. Then you can say that we are following DevOps or anything. Again, the summary, as I mentioned earlier, this is all the part of your job responsibility of a DevOps engineer. Plan, code, build, test. These are the CI/CD steps. This comes again, the CI/CD. This comes the operations parts, the Kubernetes cluster, the containers, hosting, monitoring, and logging. Obviously, this comes under the Prometheus, Grafana, and those tools come under this monitoring thing. And this is some sort of a sample diagram. So there are a lot of tools. Again, as I mentioned, that for a DevOps engineer, there are a lot of tools for one thing to do. So for deployment, even Docker is one way, AWS has its own ways, TCOS is one way, Kubernetes is again one way to operate on things, Jenkins is one way to do pipelines. There are a lot of other tools as well. Monitoring, there are a lot of tools to do monitoring. So similarly, there are a lot of tools that you need to be familiar with. And somebody CI/CD release once a week, at least you should have this in your company, that you should be releasing the newer version once a week. Microservices, there should be loosely coupled components, as I mentioned. Shared responsibility between different teams and different members, rather than as previously there was shifting blames. Now you have a shared responsibility, and infrastructure should be obviously in such a way that it can scale. And for that, cloud, containers, Kubernetes, they help a lot. And for a DevOps engineer summary, what if you ask me that what advices should a DevOps engineer be capable of? So I would say that he or she basically should be tool independent, first of all. So as I mentioned, that there are a lot of tools for one thing. So you should be tool independent. You should know the basics, you should know the concepts, you should be expert in one or two of them, but at least you should have that thing to learn a new tool. You should not be hiding that, no, I cannot learn a new tool or anything. You should be adaptable, as I mentioned. So you should be adaptable to new tools. The real issue comes that what happens is, and the next part is able to learn and unlearn. So what happens is that in our industry, especially in the software industry and especially in Pakistan, what happens is that people, when they get hired in a company, they tend to stay there and they tend to just learn whatever they learned in the first few years of their experience. So now they say that what we learned was the best thing, and it should happen that way. So change is not accepted in our in any companies, for that matter. Change is not accepted. So even if you know that it is not a good thing, and the other new tool is a better tool, so as a DevOps engineer, you should be able to learn new technologies which are good, and learn the previous technologies that are now obsolete, rather than just sticking to one that was used in 2010. Rather change it, be adaptable to the new tool, be acceptable to the new tool. New thing obviously would have its own benefits. and also have some development experience. Try to learn basics of programming at least that I mentioned. Then you would know. So yeah, that's it from the basically class. This was the introductory class. If I show you the course contents, whatever I mentioned over here. So if I show you basically the course contents of what we teach in the course, so you get the better understanding of what we offer. So yeah, this is an 8 weeks course. And if you see the course outline, so the first week, again, it would be introduction to DevOps, some things that we discussed already, and obviously some things would be discussed in detail, and GitHub. So you would be getting to know GitHub, how creating accounts on GitHub, and those things. Then week 2 would again be for GitHub branching, pull requests, stashing, tagging, all of those things. Then coming to containers. So what Docker containers are, what is the difference between a VM and a container, working on the Linux Ubuntu subsystems. So we would be using Linux for it, installing Docker, running containers, creating Docker images. What are Docker images? How to create a good Docker image and Docker files. Fourth week again would be for Docker Compose and CI/CD. So basics of Docker Swarm again, just the only basics. We have removed Docker Swarm from our course because it's now obsolete and people are moving towards Kubernetes. So basics of Docker Swarm, basics of CI/CD pipelines, intro to GitHub Actions. Again, Jenkins is the major tool that we will be discussing, but we will be touching on GitHub Actions as well. So again, CI/CD using GitHub Actions, and then creating pipelines using Jenkins, how to install it. Then Kubernetes, we would be going into details of the different controller concepts of Kubernetes, the Kubernetes architecture. Then again, week 7 on Kubernetes, and Helm charts, how Helm charts are created and what are Helm charts basically. And then the last week for Kubernetes, some things that would be left, and infrastructure as code. So we would be covering Terraform, basic Terraform. We would be creating resources on AWS using Terraform, and basics of Ansible. So we would also be discussing the difference between Terraform and Ansible, and using Ansible to change, basically install software on some instances. So yeah, this is the 8 weeks course that we would be covering. Each week you would be learning a new tool and all. Nice session. What Terraform and Ansible do for us? So again, Terraform is an infrastructure as code tool which is used to create resources. Ansible is the tool to for configuration management tool. So basically, it is used to uh, install software on already existing servers. For example, I have 10 servers and I want to install Git on it. So Ansible would be used. But if I want to create 10 servers, then Terraform would be used. What is Helm? Helm is a package manager for Kubernetes. So you have basically Helm is a package manager. So when you are deploying on Kubernetes, the Helm is now the default sort of packaging, how to package your application in a better way for different environments. So Helm is that. How good is the freelance market for DevOps compared to other fields like software development or machine learning? Again, so you can see that DevOps, the point being is that DevOps is a niche field. There are quite less resources in DevOps who are DevOps experts, at least as of now. And companies are willing to pay good amount because, again, as I mentioned, you would be handling the production servers. Whatever good software you write or a software developer can write, at the end of the day, it needs to run on a physical server, and that a DevOps engineer would be doing, that an SRE engineering or a poor ops engineer would be doing. So you can have a good DevOps, or you can have a poor ops engineer only. But if a good software is written by a good software engineer, but it's running on poor infrastructure, that means that it's not worthy of that. That's why DevOps engineers are in demand as of now. What that's at the least what I can say. If you want, basically, you can look at yourself about DevOps jobs and DevOps job market. I have shared some trends, but you can see the details of it. How do you recommend one to build his or her portfolio of DevOps? So first question, obviously, have GitHub. have public repos, have your public presence, have public portfolio of it. In our course, even we use public repos and public things, and all of the work that you do in the course is in your public GitHub repo that you can show to anyone. Even the project is public repo, you can show it to anyone, and the project, I can assure you, is of industry standards. Do you recommend someone having development experience of 4 to 5 years switch career towards DevOps? I would recommend, because in the future, or even now, I am seeing job opportunities where they say that you should have development experience as well as DevOps experience. So if you are a person who has 4 to 5 years of development experience and you know the DevOps as well, you know the all the fundamentals of DevOps as well, then again your profile will boost in that matter, because you now know two fields or two technologies, and that is much preferable. Please, any subsidized fees? So for fees, obviously, uh, dice, you would have to contact dice admins or those things. But yeah, that's it from me, at least, and I don't see any other questions as well. So yeah, we can end it on this.
Yes, thank you so much, everyone, for joining us today. We hope you enjoyed the session. We have mentioned an email in the chat section. You guys can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk. Thank you so much, Mr. Ali, for conducting such an amazingly informative session. That's all for
Thank
today.
you.
Allah Hafiz, everyone.
Allah Hafiz.